Lesson 4.9 is, we're still dealing with the quadratics, but now we're going to have quadratic inequalities. Now if you remember, an inequality is instead of equal signs, we're going to bring in our less than or equal to's, greater than or equal to's, which means our parabolas will be solid or dotted, and you'll either be shading inside or outside of the parabola. So we get to go back to graphing, so it's a nice review of graphing. So most of this, everything in this, well, most of this is stuff that you know, and it's just kind of tying it together. So this quadratic we have to graph, which means we need the vertex and our pattern of change, and that's enough for us to get the graph on there. No parentheses, so this is standard form. We graph standard form. Do you remember that little formula for the vertex, x equals negative b over 2a? Well, here our b value is whatever's with the x, which we're missing that term. So this is one of those where the b value is 0 over 2 times a. Well, 0 divided by anything is 0. So our vertex, I know, is 0 something. And then how do you get the y value? You just plug in your x to get the y. So 2 times 0 squared minus 6. And then when you do all that math, we end up with a negative 6. Pattern of change, take your a value, which is 2, times a 1, times a 3, and times a 5. So you have a 2, 6, 10 pattern. Over 1, over 1, over 1. Okay, so let me zoom in on the graph here. What did we say the vertex was? 0, negative 6. So here's our vertex. And then our pattern, I'm going to go up 2 over 1. I don't know if you guys can hear my dog barking in the background. Up 6, 1, 2, 3, 4, 5, 6 over 1, and up 10 over 1 is off the graph. But here's what we have going on. Now before we draw on the parabola, because it's going to be really tempting just to go ahead and draw it and move on to the next problem, we are actually dealing with an inequality. So solid or dotted parabola, and if we look at it, it's a less than or equal to. This is going to be solid, so we'll just draw this in solid. Now the shading that we do, it's kind of, we're used to shading above or below. This is kind of a shading inside versus outside. If it's less than or equal to, here's one thing you can do. You can go to your vertex. Now less than would be a below than. So I'm going to go below the vertex. I have to shade down here, which happens to be, let me see if I can do, it happens to be a shading below or outside, like this. So if it's a less than, just go to your vertex again, go below it, and we can say, oh, below happens to be outside the vertex, so shade everything on the outside. Alright, so now we're going to have a system of inequalities, which just means more than one parabola on the same graph, which is fine. We did this with our linear straight lines also. So it's just a matter of getting the vertex and pattern of change from each of your quadratics. Our first one here in red is in standard form, so we'll do our x equals negative b over 2a. Again, you notice we're missing that b term, so it must be a 0 over 2 times 2. 0 divided by anything is 0. And then the y, we just plug in that 0. Do the math, and we end up with a negative 4. So that vertex is 0, negative 4. Pattern of change, take your a value, which is this 2, multiply it by 135. So we're going to have a 2, 6, 10 pattern. I'm going to go ahead and graph this one. 0, negative 4, up 2 over 1, up 6 over 1, oops, and up 10 over 1, which is off the graph. But at least we know that that point is out there somewhere. Now before we draw it in, let's decide solid or dotted line. It's a greater than or equal to, so that is solid with that or equal to piece. Oops, missed it a little bit, but there's our solid line. And would we be shading inside or outside of this parabola? So we look at it's a greater than or equal to. So go to your vertex. Greater than is above. So you can see that above is inside this parabola. So I'm just going to go ahead and put some arrows just indicating I know to shade inside that parabola. Let me see what the other one looks like, and then we'll go from there. Alright, this next one, we're going to graph this. I'll try to do this down here. It's really nice when they give you vertex form, because then you can just look at what the vertex is. Tricky x, you have an x minus 1, which means we're going to use a positive 1, and then a positive 3, and then our pattern of change, take your a value, which is a negative 1 out front, so we'll have a negative 1, negative 3, negative 5 pattern. So if I go to the graph, I go over 1 up 3, and now I need a negative down 1 over 1, down 3 over 1, down 5 over 1. And then before we draw it in, just look to see, should it be a solid or dotted parabola? It's a less than, so that is dotted. So I'm just going to draw the best dotted lines I can, trying to be nice and neat. And now the shading. Should we shade inside or outside of this parabola? So it's a less than. So if I go to that vertex, and I'm going to be less than the vertex, which means below. And you can see that below is inside of this blue parabola. So that's where I have to shade, on the inside of the blue parabola. And now I'm looking for, where's the one region that gets shaded by both parabolas? It won't always work out this way, but in this case, it does happen to be this inside area right here. But again, it's not always going to be the intersection like this, so just make sure you look carefully. But this shaded region inside here, that is the solution set. Any point that's inside of here will work in this equation and in this one. Alright, so another thing we look at is how to solve a quadratic inequality algebraically. So we've got some steps to follow for that. Go ahead and just put the video on pause, write these down, and I'll go through an example with you in a minute. Alright, so here we have a quadratic inequality. We're asked to solve algebraically. So you want to just, in standard form, get everything on one side, 0 on the other side, and we're going to go back to our factoring on these. We're going to just factor our standard form. So we have just an x squared here, so we look for factors of 28 that will add up to a negative 11. So what will multiply to 28 but add up to a negative 11? Well, 7 and 4 add up to a positive 11. What if we make them both negative? Negative times negative gives you a positive 28. If you add them, that's how we're getting that negative 11. So we'll say x minus 7, x minus 4. I'm just going to go ahead and say equals 0 for now. We'll deal with the inequality in a minute. And then we go ahead and we solve for x. X minus 7 equals 0. X minus 4 equals 0. And we get two solutions. We have a 7 and a 4. And so what we do is we're going to put these on a number line. So we draw ourselves a nice number line. 0 will be over here. 1, 2, 3, 4, 5, 6, 7, 8. But really it's the 7 that I want. And we need to determine, we're going to put circles where the 4 and the 7 are, but should they be open or closed circles? So now we're going to go back and pay attention to this inequality. A less than is going to be just open circles. So I need an open circle, 1, 2, 3, at 4, and an open circle at 7. So from here, we just have to decide, are we going to shade in between the two on the inside, or are we going to shade going out? And this is where we just do a test point. If you test the point 0, as long as 0 is not one of your solutions, that means just plug in a 0 for x. So 0 squared minus 11 times 0 plus 28. What do we get? Those zeros cancel away. We have 28 is less than 0. Is this true? Is 28 less than 0? And we say, well, no, it's not. 28 is not less than 0, which means that's not true. So 0 is not a solution. I cannot shade where 0 is. Since 0 is on the outside, that means I can't shade on the outside, which means my shading has to be on the inside, in between the two. Just like that.